Okay, for those who are joining this live stream, we are doing a de-experimentalization review. So there are functions that are tagged in Wolfram Language documentation as experimental, and we're trying to figure out whether we can consider them final, whether they need changes made before they're final, or what. And we're going to work through a sequence of different areas. So we're going to start off with system modeler. All right. Boy. Okay, so is Malta here? Is Malta here? Is Roger here?
Malta is here.
Well, then he should say something, please. You need to actually say something. Hello?
I'm trying.
Okay. And is Roger here? We need Roger Jermanson also here.
Can you hear me now?
Yes, he can. Where is Roger? He needs to be here.
Okay. Yep.
Okay, I don't understand what these are. These are not system symbols. What are they?
Formats.
Right. Formats.
Okay.
But they are tagged experimental too. So this includes everything: system symbols and all pages tagged experimental in that area.
Okay, so my first question is anything in the system modeler area non-experimental at this time?
No. It's all experimental.
Okay, so it's kind of a big deal to take it out of. What is the state of entityifying things in the system modeler domain?
It's work in progress, but we should have something for 12.1.
Let's talk about what that design is, because I think that may affect some of what's going on here. I mean, so for example, from my point of view, let's look at, I mean, this is alphabetical order or not, system model itself. No, I don't buy this. Where is system model itself? System model itself is experimental here, and you propose to de-experimentalize this, right?
Yes.
That's the idea. Whew. There's just an awful lot of stuff in this. We need Roger here anyway. I'm not going to discuss this without him. Is he coming?
We could switch to the second one till we find Roger.
Let's do that. Okay. Okay, so is Alan here? I guess not, but Francisco is here, perhaps.
Yes, hi. Yes. So the street address, it's being improved a lot with the new server, which is on its way.
When is that supposed to go into production?
Well, we are doing the final changes in the calculate side, so that we should do the final test this and next week at most, and then will be the planning to go live. So we hope before the conference.
I should certainly hope so. Yeah, I should certainly hope so.
Yep.
And hopefully we will be able to show some additional functionality there, right? Made possible by the new GeoServer.
Right. So the idea is that with the new GeoServer, we will be able to expand the current functionalities. First, we are improving the current ones, like, for example, this street address, which has improved a lot.
Okay, so look, I'm not sure I buy this, because I think that this is really a street address location, right? Because it's going to return a geo position. I would expect that in the interpreter that says called street address would return some kind of canonicalized street address. You know what I'm saying?
Right. That was a discussion we had a long time ago. You remember about having this more computable way of expressing addresses, which right now we don't have.
So, I mean, to me, there's probably should be a function geo address or something. That is the analog of geolocation, but a symbolic representation of an address. Am I making sense? As an association. And to my mind, something called street address should return one of those, and perhaps this should be street address location. Am I making sense?
Yes, I will agree, but well, for now that we don't have yet any street address canonical form.
I'm aware of that. So the question is, I think we should keep this experimental, and I think what we should plan on doing, I think we could introduce the street address location, right? And we could, I mean, for now, this could go on returning geolocation, but in the end, street address location should return the geolocation, and street address should return a geo address object. Okay?
Okay, so for now it will be kept as experimental so that we can do that change.
Yeah, but I think we might as well introduce a street address location and start moving code over to use that. Am I making sense?
Yes, I think. Yep.
I mean, it's even arguable it should be called address. No, I think no, street address location is okay. Or, yeah. Now, I mean, in terms of the geo address, have we already designed this?
No, we only had one meeting and we never finished that.
Okay, so I mean, I think it should be, whatever the thing is, city, ADM, administrative division, city, whatever it is, right? So it should be something that looks more or less like this. And I think given the new geo server with its new geocoding capabilities, we should start actually building geo addresses. Okay.
Okay, yeah, I will talk also with Jose to see how we can design this. Yes.
Fine. I mean, I think fundamentally, this is what it should be roughly like. It should have certain elements here. It's fundamentally a hierarchical specification where these are, street number or something. I don't know what it's called, but in the end, it gets down to street number 10 or whatever else. Sometimes those get funky because they can be. I'm sorry. Hello.
Hello. It's Devendra, yeah?
I'm sorry. Who? What?
Devendra, yeah?
Oh, Devendra, we are still waiting for your area.
Sorry. Okay. Sorry.
Right, and obviously all the elements should be in general optional because not all the addresses use the same elements, and etc.
Right. But I mean, I think that this should be an entity. The street name itself, I guess, should be an entity, although that is, that's complicated because, that means we're naming every street in the world. I mean, we're turning into an entity every street in the world, but we have enough data to do that.
Right, that will be hard. And also, even for cities, we don't have all the cities because sometimes they are not considered city, but probably for the address point of view, it's a city. So that's also another issue we might have.
Well, fine. Okay, fine. I'm saying this is something we need to develop. Okay, so this is a okay, but anyway, so please introduce street address location. We'll leave street address for the time being. Maybe we don't even need to document street address location yet, although we could. And I would say you could make street address location and make it not experimental, because I think that one is going to be just fine. Am I making sense?
Right. Well, yes, I think so. Even when it would be nice if this street address location will also eat this geo address to become a position. Well, no, sorry, that should be the task for your position itself. That's right.
Yeah, I think so.
Yep.
And no doubt geo address can cache a geo position inside it.
Sure, that could be another element. Sure.
Right. Okay. Do we have Roger for the system model discussion?
He isn't. We weren't able to find him yet.
Okay,
Do you want to move on to asymptotics?
I'm going to move on to asymptotics. I'm not going to do it without Roger.
Okay.
Okay. So thank you, Francisco. If that's all for you, you can disappear.
Yes, that's all for him.
Okay. Bye. Thanks a lot. Okay, asymptotics. We kind of need Roger for this one as well.
Actually, Roger just left, but the key point is that I mentioned over there that Roger would like this to be done as part of the asymptotics review for 12.1, and because we have a few more functions coming in over there. But they're all ready for.
So why is it in this meeting?
Right, because I mentioned to Raj that we are ready since they asked yes or no, the answer is yes, we do want to finalize them, but it would be better to do them as part of the general asymptotic review for 12.1. And they're all
Okay.
kind of ready to go. There's only one design change which we need, but
What
it'll
is that?
that design change is that we have this new thing called asymptotic, and we would like to use a limit-like notation in addition to what we're allowing now, because we want the leading asymptotic for something, let's say. And
What's it called? Asymptotic?
yes,
That doesn't sound like a good name.
yeah, but that's part of the larger thing for 12.1. So I mentioned to Raj that we could actually uh, basically delay that, which will happen very soon. We are ready to discuss that as well.
All right. Okay. Then let's not do that here.
Okay. So
Okay. Well,
you.
then I guess you're off the hook.
thank you.
Thanks. Okay. Bye. Okay. So are we ready with Jason and Michael?
Michael won't be able to attend, but Jason is here.
Okay. Listen. This is the first in the series of meetings. I'm not doing these meetings without, we can try and do this with Jason, but if we get stuck, it's going to wait until Michael is around.
Okay. I mean, I did check with Michael. He said it was fine to go ahead with Jason. And if we do get...
I don't care. I insist on having the senior people involved in each of these areas here. Okay. Otherwise, we're just going to get things messed up and we're going to get, oh, but I didn't mention this or that. Okay.
Okay.
All right. I don't understand how we cannot be de-experimentalizing Atom, but we are de-experimentalizing all the attributes of Atom. That just seems wrong to me. But Jason, can you speak to this?
Yes. So I'm very new to what de-experimentalizing something is. So
it means
Atom,
we're committed to it for the rest of your life.
Right. Okay. So Atom, everything that we've the syntax we've documented so far, we would obviously continue to accept. As I use it, I sometimes want to add in maybe an additional syntax and additional properties.
Let's talk about that. Okay. Yeah. Well, I mean, okay, but so you believe that the system as a whole is working decently well?
Yeah, but I haven't gotten a lot of feedback from users yet, and so I kind of want to. In general, that's my idea, that I want to get more feedback from them before de-experimentalizing like molecule or molecule pattern.
Wait a second. There's no point in not de-experimentalizing. If we're de-experimentalizing a bunch of these other things, there's no way. I mean, it's crazy to de-experimentalize some tentacle function that depends on molecule while not de-experimentalizing molecule itself. Sorry, that just doesn't make sense.
Okay.
Here's a question. So I was reading Science magazine, which I don't do very often, but anyway, there's an article in it about these trefoil knot shaped molecules made of carbon. Okay. There's even a carbon nanotorus here. So my question is, can we represent these things? We should be able to, right?
Yeah, so if they can be represented by a connection table, then we can. Generating the coordinates for those more intricate and convoluted molecules is much trickier.
Yes. Yeah, well, okay, but let's talk about what you want to do with Atom. I mean, the answer is we're not going to de-experimentalize tentacle functions without de-experimentalizing the core function. And if you don't feel ready to de-experimentalize the core function, we're not going to do it for this version.
Okay, so yeah, I mean, just in general, I do feel that it could use some time and some feedback.
Okay, well, tell me so for example, for Atom, tell me what the things that you think should be changed or could be changed are.
Let's see. So users, I've had a specific request to have Atom level meta information. So that's simple. Like we could just add a meta information
about what?
So you could put in what the source was, what the name was from the whatever file that you brought it in from. This would be the.
So hold on a second. This is in the name value. This is some other thing for the name value sequence. Is that correct?
Yes.
By the way, this is wrong. If this should say comma dot 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 here, if that's what it means. Is that what it means? Not just dot 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 there.
That is exactly what it means.
Okay, so can please fix. Okay. Okay, so you're saying putting in meta information there. Is that right?
Yeah. Yes.
Okay, so these are properties that we're supporting right now: formal charge, mass number, unpaired electron count. So what are additional things that people want?
So you could, we're interested in being able to do constrained embedding when you create a larger molecule, but you want to give coordinates to a small subset of them, and then we would generate the rest with the caveat that the specified ones match up. And so that's something you could add at this level of the expression.
The specified ones match up.
Right. So you have a large molecule that has a little benzene ring, and you specifically want that benzene ring to be in the XY plane at the origin. So you specify the coordinates of some of the atoms.
So okay, so you're saying that you would put coordinate things into the properties there.
Right. The user could specify it, and then when you create the molecule, you parse that and generate the coordinates at that time.
Okay. So I mean, you should probably let's get a draft spec for that. Sounds reasonable to me. Okay. All right. What is just for my information? What's the current frontier of what you're doing with all this molecule stuff?
What I'm doing for I'm looking at molecule fingerprints. So this is something that I'd really like to flesh out and bring for the next version.
What does that mean?
So molecule fingerprints, you take the molecule and you create a bit vector of 2048, for example, ones and zeros that are constructed in many different ways, and then those can be used either for substructure screening or similarity comparisons, or for machine learning purposes.
Okay, so this is a net encoder for molecules, basically. Or a molecule hash or something.
But it is, and it has there are a few extra caveats. One that's very interesting, that there are these types of fingerprints called pattern fingerprints, where if you have a substructure, any bits that are turned on in the substructure will be turned on in the molecule's fingerprint.
Right. That's a hierarchical hash code of some kind, which
right. And people have hooked this up to databases, to a PostgreSQL type of thing, to make for fast substructure searches.
Okay, that's interesting. All right, but I mean, we're probably going to have molecule fingerprint or some such other thing as a function.
Yes.
Which will have various different kinds of fingerprint things, which will return some kind of vector.
And we might need to have some molecule fingerprinting function that you would then, in order to generate them. But that's
that's what I just said. That's what I just said. A molecule fingerprint function that generates the fingerprints, right?
Yes, absolutely.
And that's extremely similar to the feature extract, right? And it has some of the same issues of forward compatibility that feature extract has.
Yes, I imagine.
It might even be a version of feature extract. It might be that you want to put it in, well, it's not quite feature extract, but it's anyway. Okay, fine. All right. So I don't think we de-experimentalize for right now. Expect to do that in the next version.
Okay.
All right. What's next here?
We can switch to resource system. I just got in touch with Roger. He's joining in a couple of minutes.
Okay.
So hopefully by the time we are done with the resource system, he joins in.
Okay. And is he needed? No. Okay. Fine. All right. So who's here representing this?
Bob and Brady.
Bob, I'm here. Bradley. I mean.
Sorry. Yep. Bradley.
Okay. So which things here have already been de-experimentalized? Resource object and all those guys already are de-experimentalized, right?
Right.
I don't know what define resource function does.
It's a simple constructor function that, if you don't care about documentation examples, is an alternative to the definition notebook. You just, as it shows right there.
Why is this the correct way round?
You mean the input order?
Yeah. Why is the name of the function second?
That's not obviously wrong. I mean,
oh, I see. Because
if f is a symbol, if f is a symbol, we can, choose it smartly.
I see. So there's a one argument form which typically makes sense.
Right.
Okay. All right. Okay. I don't have an objection to that. Resource function. Well, this is the main.
This is the main thing. It took off in 12. People are using it.
Yeah, I think
the design is good.
Yeah, I think it's all fine. Now, one question that I have is the return value of an unevaluated resource function.
Right. We want to have the formatting rules in place for things that don't have definitions as a default.
Okay, fine.
We can do that for 12.1. Yeah.
Fine. Please do.
Yeah.
Okay.
I think we might need a way to let people opt out of it in certain cases. But yeah, we can talk about it later. It can be by default. It can be.
I think the standard form for the thing should be. I mean, the input form can show you what was underneath there, but the standard form should just be a nice gray blob.
Right. Yeah. If it's just formatting rules, actually, it probably should be safe.
Roger here.
Hi. Yeah, I mean, it should come back looking like that. In the case where the thing is fed garbage.
Right. Yeah. A number of them it is. Yeah. So that one has.
Well, that one did, but how come some of them
especially
do
anything that has an operator form, which this one does, almost certainly has the formatting rules because the operator would look like garbage otherwise. Otherwise, for now, it's been by default it exposes the internal symbol.
Okay, well, so don't do that.
Can we
fix that ASAP and packet update it? Because I think that will be a really desirable thing to get fixed.
Sure.
Okay.
Sure. We can do that as a packet update.
Okay, fine. Let's make it happen. Okay, now let's look at these other ones here. Okay, so resource register. Why is that not ready to de-experimentalize?
We talked about this resource system path thing that we want to put in that is high on my to-do list. It will be integral to this function, and we don't really have a design for what elements we're going to allow on that path.
I see. So this is a resource system where you're saying it can be the public cloud resource system and my private cloud resource system. Is that right?
Right. Or yeah. Right. Or this can resource. Are you asking where resource register is, or are you talking about the path thing that I'm talking about?
I'm talking about the path thing, which is necessary.
Right. Where to look for resource objects. Exactly. So it could be multiple resource systems. It could be, the local. You could take a string like local, which means look for locally cached things, and the order of it matters. So you might just be rearranging things that are already there. So it's like the persistence path. In fact, I think it should take the same persistence locations as values. It should take URLs, but maybe only with a URL wrapper. We sort of have to figure out those details of the design for the path, and I don't want to de-experimentalize this until we do.
Fine. Well, can you get that on the agenda soon? Because I can't imagine it's going to be that difficult to make this resource path. I mean, it presumably should be called resource path.
Resource system path, I was thinking, but And we already have resource system base.
Okay, fine. So it's $resource system path.
Right.
And then the option is resource system path.
Yes, that's the plan. Yeah. I think the only thing that needs to be cleared up is what the design of the elements on the path is, what we support.
I'm sure some of it is URLs and some of it is persistence locations.
Right. But yeah, and
probably something-
Bradley and I've talked. It might fall into that system servers design as well. A naked, how to interpret a naked string, there might be ambiguities, but if you wrap everything in something like URL or cloud object or file, then it will be.
Why don't you get it built with that assumption, and then we'll worry about the naked strings later.
Yeah, sounds like a plan.
Okay. By the way, in resource register, I would recommend that. Well, I mean that can be referenced by name. I mean, I would just have resource register of quotes name as the next line here, rather than having that have to. I mean, we don't usually do that where we explain that there are multiple possibilities all in one line. It's not terrible. Okay, resource submit.
Right. So right now, this is typically used without knowing it from the definition notebook, right? It's called underneath the hood from a button. This is a programmatic way to do it, and
Yep.
this, the 2-argument form for an update. I don't know. I guess it's fine. I'm not convinced that it's the best possibility. I don't know. Nobody's really using it, so I didn't think it was really worth the experimentalizing.
Well, we've talked about exposing versioning a bit more, so that
I don't think this is ready to do experiment.
affect that. Yeah.
Resource update. That's something people should be using, right? I mean, I've gotten, messed up a few times because there is a more recent version of a resource, but I didn't get it.
Right. So right now, if all we wanted was the dummy form where use resource update, it gets the latest one, it would be good to go. But we want to specify a version. We spec'd out a design for that a week ago, and it isn't done yet. So that's something that needs to be done.
But I have a question here. I mean, what is the messaging? So I'm using a function. There's a more recent version. How does it message me?
Right. So typically it will happen the first time you invoke that resource in a new session after an update has been published, and it'll give you a message that says there's a more recent function, use resource update to get it. And then there's also this button in the message that I don't particularly like, but it works.
Can you show it to me, or is it not? I haven't seen that one yet. Specking the button.
Sorry, I have like a development branch checked out right now on this particular issue, and it would probably be bad if I tried.
Okay, all right, fine. But that's something we have to look at then in the design.
I think that makes sense. Yeah, but it needs to allow a version specification, whether it's an option or as an argument, and that needs to be cleared up. The $publisher ID actually just last Thursday, I committed the change that needs to be done. So I think I just need to update some documentation, and we should be able to do those.
Are we sure they're correct?
They're pretty simple, but we can determine that right now.
Well, I mean, the main issue is that we want to have this idea that by default people are publishing with their own names, so to speak.
Right.
And only if they want to, they all can be under, the Octopus Lab or something, whatever it is.
Right. So yeah. And in 12.1 $publisher ID, if you just evaluate it at the beginning of a session, you haven't set anything. It'll call the resource system, assuming you're cloud connected, get your default publisher ID and show it to you. In 12.0, it just returns unevaluated. Right. This is the change that I just committed on Thursday.
Okay.
So I need to document that still. The changes in 12.1, probably today's build.
So if I say $publisher ID equals, pink elephant or something.
Right. That's the only way to do it now. So yeah, that then when you use resource submit, it will attempt to submit it as pink elephant. It'll check that your cloud connected Wolfram ID has access to the Pink Elephant publisher account, and if so, submit it using Pink Elephant.
Okay.
And that only persists over the session. So my thought for like how you set your default would be through like a web interface. Like when you change cloud preferences, we could have the same thing for resource system rather than in language.
Fine. But then that's a thing in the cloud account. Yeah.
Yeah.
By the way, I'd like to say, and it's related to the system servers issue, that anything you can set in the GUI for the cloud account, you should be able to set programmatically.
Okay. I have not had those conversations with cloud just yet, but I'll make sure that's
Right. I
a
mean,
note
it's
for
similar to set options of $front end.
it. Mm-hmm.
But, I think we need a general way to do that. And we might need a way. I mean, we may even need a way to do that for external entities like the things that come up in the Wolfram application server stack. Okay. All right. Now, resource remove.
I think that should be deprecated. We have delete object. It's more general and it does the same thing.
All right.
So
if we think that's the case, why don't we proceed to deprecate resource remove?
Fine with me.
Do we need any sort of functionality for unregistering something without deleting it? Or is that just not?
There's a resource
I haven't thought
system.
through that.
There is
too far.
a tool for doing that in a private context, but yeah, we haven't.
Resource unregister or something?
Resource
That
unregister.
seems
Yeah,
hard.
and I don't think resource remove is the right symbol for it anyway.
Right.
We can revisit that. I don't. Yeah.
Okay.
Right. We didn't resource search was the last one there. We didn't mention it changed significantly in 12.0. It returns a data set instead of a list of objects. But yeah, I think that sort of has the same resource system path thing going on. Now, resource search, it could be de-experimentalized because the path is just sort of an extension that wouldn't break anything, but it's an important extension. So I don't know how we handle that as far as experimental tag.
I think we could de-experimentalize it, given that.
Right. Yeah, it's an important feature, but it won't break anything to add it because it'll be in like a method option or its own option. Research.
Fine. Let's de-experimentalize resource search. It seems I don't see a problem with resource search right now.
Okay.
Just looking through this documentation.
The list of things in the second table.
Items and methods are not links?
Oh, that's we should.
Which?
The very last table, the left
That's a bug.
column should be
it's a
templated.
bug.
Yeah, and the values of the strings in the second table aren't clearly right. So, like that objects will give you the pre-12.0 form of resource search, where it gives a list of resource objects.
I don't think that's bad. Why isn't it called list though? Why isn't that one called just list?
Yeah, that could be fine. I think we came up with this in the search consistency meeting at one point.
Well, then we don't want to mess with it if that's what search consistency implies. I mean, objects may be a bunch of resource objects.
That's exactly what it is in this case. But like in text search, they could use the same thing, and it would be content objects. And in web search, they could use the same thing, and it would be whatever their objects are.
Okay.
So yeah, I think we could. Yeah, I'll template those options, and we can de-experimentalize it.
Okay. All right. Fine. So we are or not de-experimentalizing $publish ID?
Yeah, I think we can. I mean, there are documentation changes I need to make, so we should. I mean, they will be in for 12.1. I don't know what the proper process is. If I should make sure those are in before I click the button, or I can click the button and then do the documentation.
I think you can click the button. I mean, once we're clear the design isn't going to change. I'm a little bit nervous about Publish ID and $Publish ID. Why don't you leave them experimental?
Okay.
For another
I mean, nobody's using them because nobody external has more than one. so it's not terribly important.
Right. Okay. It's a question from our live stream from Sander asking about will there be a session on function repository reviews with the possibility of taking popular function repository functions and adding them to the core language? The answer is yes, we intend to do that. We don't have that scheduled yet. And I don't know whether we yet have a process for it in terms of surfacing, our favorite or most used functions. I think it's really a question. Can you guys comment on that, or is that for other people?
I mean, we have internal data about most used that we could use to choose some, but we don't have upvoting or anything.
No, I understand. I mean, it will be interesting for you guys to try and surface the top 20 things that you think might be put in the language.
Yeah, that'd be cool. I'm sure I could work with Danny. And
I think that would be very useful to do that. I mean, there'll be a trade-off because there'll be ones where we got a bunch of background noise here. There'll be ones where it's very straightforward to put them in the language, and there are ones, but it isn't all that important, and there are ones where it's quite difficult, but where it is more important.
Right, and for putting an external or any thing in the function repository, we don't care that the code is perfectly efficient. I mean, it doesn't need to be optimal, but there'll need to be an actual review of the code.
Sure.
And possibly a full-scale rewriting in some case where the design is good, but the implementation is bad. So,
yep.
So yeah, it's tricky.
Yep, but I mean, I think we should at least get our list of top candidates.
Yeah. I think we could do 5, and it would fill a long meeting instead of 20. But we can pull out a few.
Okay, please do. All right.
Why isn't there like a ranking of how these functions are doing? In terms
because hopefully we will get a ranking of that, but there will be some confounding factors like how long ago was it introduced, was it advertised in a particular place. I think there will be some very fine details that could affect usage patterns in ways that aren't informative. Like, for example, a function could be widely used inside another function that is the real design thing that anybody cares about. But the thing on the inside could nevertheless be called every time that function is called, just because that was conveniently how that function was written.
In fact, the top usage one is the exact case.
What is it?
Oh, it's like internal block or an inherited block or something that one of the general utilities things that's been around for a while that is now in the function repository, and there's 3 or 4 functions that in the function repository that also use it. So
I see.
I think it's most of its uses come from dog.
That's okay though. I mean, I think
it is
straight top list anyway.
Yeah, I think that is fine. I don't think that means we rule it out.
No, but it might be that the factoring. Well, anyway, it's by the way, I don't even know what's happened to the additional content acquisition from our various obvious mineable sources.
Yeah, I mean we've hammered out most of the low-hanging fruit, and now we're getting into more.
Are you sure? Because I mean, there should be a list of sources of content, and like I know you haven't mined the NKS. I mean, the stuff you've mined is stuff that's already been documented, right?
No, we've done. I mean, Enrique has done some NKS. I don't know how exhaustive it is. Enrique,
I haven't seen a single thing come through from that.
We can take a look at that list. It was something that Sushma had put together, and I don't think she's had a chance to revisit in a while. So there hasn't been.
Seems like we should continue pushing that.
As much focus on that since she moved off the project.
Yeah, we shouldn't talk too much about it without Sushma's input.
Okay, fine. But I'm saying, can you please bring that up again in the next meeting we have about function repository?
Yeah.
By the way, probably at the point where we could live stream some function repository meetings as appropriate. Okay. Ben, on the live stream, it seems like most in the repository right now is staff created. Wonder if outside creators will get credit. Absolutely, they get credit. Yes, some people on the stream, I think, have contributed. Like I think Sander has contributed quite a few things. Okay, I think
I don't know what percentage. It's certainly more than 10, less than 50. That's external.
Yeah, I mean, it's probably similar to what happened with Demonstrations Project, where it's now, 98% or something, or 90, external, but it just takes a while to get that started. But
we also have a lot of content we want to put in there anyway. We've been looking for a good way to release it, so our count is going to be increasing for a while still.
Right, and for people on the live stream, contribute to the function repository. Okay, let's go back here.
Okay, I'll drop off.
Yep, thank you very much.
Bye.
System
Thanks.
modeler. Okay, so this is a big, hairy piece of design. What do we know about how people have been using this, Roger and Malte?
I mean, we have heard feedback, and I would say it's mostly positive, and nothing major. Like there are some users have found minor bugs, but none has come back that is actually a showstopper or anything that actually changes the design.
So, I mean, one issue which continues, my God, this is so complicated. So what has happened to the entityification of these things?
I mean, we had a meeting like 2 or 3 weeks ago, and we discussed a bunch of avenues. One of them was having an entity store, which is basically a way to access the system models, which we've been working on. And that's the part that we should have for 12.1. I mean, there's already a pretty close version in 12.0, but it's very undocumented. For 12.1, it should be cleaner and probably have its own entity documentation page.
One would assume. So why is for system model, why does it exist? Why is that not just an entity with entity?
Well, just for starters, if you scroll down to the first example, it should exemplify why you want something nicely typeset. You can clearly see what it is, while in an entity, you just get a name.
Well, I mean, that's not necessary. It's not a self-evident feature of entities, but I understand that point. You could make net model is another example where you actually are getting, well, net models are not entities, right? Net models are coming from, so what's the relationship between the resource system and system models?
This discussion again. We want in the future to be able to distribute examples of system models in the entities in the resource system, but we haven't gotten there yet.
Okay, but so why is it not the case that every system model is basically a resource object?
Why would it be that?
Yeah, why would it be?
Because it's a convenient way to document. It's a convenient framework to use.
No, I mean, we have a full library. I mean, every system, first of all, a lot of them are components, which makes no sense on their own, like a resistor.
Fine.
Or an inductor.
Okay.
A circuit is something that's fully put together, whereas a resistor or an inductor is not. And out of the 6,000 objects in the standard library, the vast majority are just components like that. They're not fully configured systems.
I understand that. So, okay, look. We've got two frameworks that exist in the system. One is entity stores. The other is the resource system.
But I thought entity stores was kind of, an extensibility mechanism. It wasn't itself. Do you know what I'm saying? We don't ship entity stores. We ship entities.
That is correct. Entities implemented conceptually using entity stores, although they're not all done that way internally.
Right. But the entity stores is itself kind of like the current extension mechanism. For
That's
entities.
correct. Yeah. Right, for entities. Now, that is, right now, the resource system is larger scale. So, for example, a whole entity store can live in the resource system. Right? Now, the question here is, what's the granularity of these things, and to what extent? I mean, the resource system has the feature that the typical.
But also, I mean, I have a meta. So first of all, the naming scheme is going to be very long and hierarchical in entities, because it needs to fit in with the rest of them, right? But also, my take on entities is that they're fairly sort of fixed. They're not open-ended.
That's true. Yeah.
You know, the fundamental thing about the modeling system is that it's open-ended. It's like chemistry. It's like, you know, it's even more open-ended than chemistry, because truly you build new ones all the time.
All right, so let's look at that analogy for a second then. Because in chemistry, we decided not to make. So in chemistry, what happens is there are named molecules that are entities.
Right.
Okay? But the representation of a general molecule is not an entity.
Right.
Right. So we have the exact same thing here.
Good. Okay, so what you're saying is there are named complete systems which are entities, although I think components could perfectly well be entities as well.
Yes, I mean, what we discussed in the entity-focused meeting a few weeks ago was that the entity store we will ship with, together with this, will be a way to represent. I mean, you can access all of these system models through the entity store, which allows you to do some neat things like navigating the hierarchy of models, which is not as natural through system model properties. But in the end, you still have a system model as an object that you can extract from the entity store.
Um,
In a similar way that I guess you can extract molecules as a molecule object from that entity store or entity. I don't know if it's a store, but yeah.
Sorry, say that again. You can extract, no, but molecule properties are from the molecule object. So the situation there is we have molecule entities, which are a bunch of named molecules. Okay. We have a molecule object, which is an extensible, it's more like an integer rather than a named, it's not like with integers, we don't have named integers. We just have, the integer structure.
Right.
Right.
So the analog in this area would be that we have an entity store with named entities with the things we ship with the product, like the standard library, which includes both components and fully simulatable systems. And then you have the analog to the molecule object, which is system model. Which is also, you can build your own system model objects. So it's
I see. So that's like net model or like molecule.
Yes.
Yeah, exactly.
All right. So let's just understand that full analogy, okay? So, I mean, one difference you have is you have hierarchical component names.
Yes.
I don't really understand how that maps into anything else. But
I'm not sure there is a direct analogy to molecules or net models. Probably not.
Well, okay, so you've got to think.
Well, there are other things going on where that hierarchy is kind of important from Modelica compatibility perspective, but it's a little bit like there are other ways to name things that exist in other databases, and we have some alignment between entities that you have different ways of giving.
Can I ask, what's happened to our effort to have a standardized browser for entities or resource objects? And to get rid of the system model examples function? What's happened to that? You guys were going to be working on that with other people, weren't you?
But we weren't the ones driving it. It was you brought up a bunch of things that needed to be there, which had nothing to do with us. I forgot what that was.
Okay, so I think Sushma might have been given that project, but since she's now been reassigned, something may have happened to that project. We need to bring that project back to life again. Who here can make sure that Sushma is aware of this?
I can let her know.
Okay. You may, in fact, be the one getting this project.
Yeah, that's kind of what I figure.
Okay, then you need to bring it back to life again. By the way, what's happened to the monitoring project? Standardization of monitoring indicators.
What do you mean, like loading things like that?
Yeah.
You mean the progress indicators?
Yes.
Yeah, that's been ongoing.
Okay. All right. Fine. So we'll see something for 12.1 for that, right?
Yeah.
Okay. So let's come back to this. I feel like I don't think it's a great idea to de-experimentalize these things yet.
It seems like we're having the exact same discussion like we did for 12.0.
Yeah, well, I think we're going to go on having that until we start seeing all these pieces come together. Because I'm worried that we're going to figure out that something doesn't really work we've got entities, resource. Okay, so resource system, presumably you could have a little entity store in the resource system of, probably in the data repository for right now, of components, basically. Let's say that you wanted to do some different kind of, I don't know, thing for, optoelectronics or something.
Right.
You don't have those components.
Right. And this, typically they're called modeling libraries in this area, and that's typical thing you ship, like this is my library of opto whatever.
Okay, so question, does that fit into the rubric of our data repository? If somebody wanted to do that, does it fit into the data repository, or is it a different kind of animal?
No. Well, we can make something fit, but let me just describe what it is first of all. So a library is the thing that we haven't gotten to yet. Function repository is sort of a single function, but we haven't gotten to the libraries of functions yet. And typically when you model, for instance, let's say you pick a domain, like the electrical domain. Then you need a bunch of components, you need a bunch of ways to connect them.
Yes.
And you need to sort of correctly model that. So you need a whole kit of things, or you can't really model anything.
I understand that, but I don't understand.
Typical.
Yeah, right. But I mean, to me, this is like a bag of entities more than it is a bag of functions.
It's not so much a bag as a very carefully constructed
whatever. I don't care
hierarchy.
I mean, it's like, but I mean, do you think a particular area of physics is like a bag of entities?
Some of them are. Some of them are.
I mean, but that's kind of what they model. A domain of engineering, a domain of physics, and if you call that a bag of entities,
one of the issues with system model is that it isn't modeling. I mean, the thing that still bugs me is the disconnect between essentially systems of ODEs, which is what system model is doing, and all the stuff we have now with finite elements and PDEs. I don't understand.
Okay, that's a whole different. Let me then address that. So first of all, you need DAs, a little bit more general than ODE.
I understand that, yes.
Okay.
I mean, that's what we have, yeah.
Right, okay. So, but there is this disconnect, so you can model an awful lot of things with ODEs or DAs, including things that you would normally think that you need to use PDEs for, by using what the hell are they called? Basically, with a big system of ODEs, where you build a compartment for each, like thermal, for instance.
Yeah.
Okay.
Well, okay. The fact that there's some way of simplifying it like that is it's not always going to work. I mean, if you're trying to do finite element analysis of some complicated shape, You're not going to be able to decompose that into a bunch of compartments.
Right, but you can't use finite element is useless for control, for instance, and signal processing. So it's the question of what is your goal?
Why is it useless for control? Why can't it be in the loop for control?
Because it can, but it's exceptionally rare at this point. It's a fraction of a percent that
I
are trying
understand.
to do.
That's not yet here. But
Right.
I mean, what's more realistic is something like a machine learning thing. I mean, like, for example, could you have, let's say that you wanted a donkey in the loop in this thing, right? You're going to make a model of a donkey, and your model. Well, I don't know. It's a bad example. Good example. Maybe there's some differential equation model of a donkey, but maybe more plausibly, let's not pick a donkey. Let's pick a sea anemone. Okay, where
What?
whatever, a starfish. I don't care. Some weird creature, right?
Okay.
Where it does various things.
Mhm.
And let's imagine that you had a machine learning model of the starfish. You didn't have a, mechanical model of the starfish that you made with ODEs and things, or DAEs or whatever, right? So my question then is, could one of these boxes be a machine learning black box?
Well, we're working on that now.
Okay.
So,
so the answer is yes.
Well, soon.
But then what that would be is presumably that will be a net model embedded in a system model.
That's
right?
Yes.
Okay.
But it needs to be exported, through Onyx and so on. And so that export is not quite there yet. It's a release or two away.
Yeah, I get that. I mean, so my question here is, okay. I mean, I'm.
But this is, if you're going to model behavior, even for it's always a question of what is your goal with a model.
I know.
Okay. And if your goal with a model is, for instance, for technical systems, these kinds of models are excellent for control, signal processing, and even simulating behavior. They're very precise. Now, for some things, you use PDEs instead, or these are called compartmentalized models versus distributed models. PDE is like a distributed model, whereas this is a compartmentalized.
Okay, but so for example, take another example, traffic jam modeling. Okay.
Yeah.
Where, one of the popular models is some random cellular automaton model.
Okay, but that's yet another sort of, style of modeling.
I get it. I mean, this big project that we can't talk about quite right here, but for a customer on traffic modeling, is, I don't know whether you've paid attention or know what's been done there. You might find it interesting because that is a whole different set of issues that come up of ways to do modeling. That's sort of a combination of agent-based and this and that.
But that's why I'm bringing it up. You kind of need to qualify what you say when you say modeling, because many people say modeling and they mean their thing. And their thing might be one of 10 major things. So if you talk to a guy in the CAD industry, when they say simulating, they always means you build a PDE and you use finite elements, because that's the only way they think.
So the problem that I have with this is we have this very general name, system model. Okay. But in a sense, it's what would be the fully qualified version of the name system model?
System model?
No. The fully qualified name, as in you're explaining why it's not a model, why it's not a PDE, it's not a cellular automaton, it's not an agent-based model. It is what? What kinds of systems does it deal with?
Modelica model.
No, that's not going to cut it.
No, but that's fully qualified what it is.
Well, okay, fine. What is the generic fully qualified, the non-branded fully qualified version of what it is?
I don't know if there is a name like that.
Okay.
Because it's not just, in the end, it does deal with event models, but not as fully as your traffic model, which probably is is very event-oriented, sort of ground up. That's what it's optimized for.
Okay, but my
events in System Modeler. Okay.
My question is, look, at some point in the future, okay, so like an agent-based model, for example, is there a way that the current framework of System Model and all of these different options and all these different things here, right, could in principle be applied to an agent-based model, or is it just totally hopeless? And these are just specifically things for essentially DAE models.
That's sort of a question of how far does the Modelica language extend in a way.
Well, but you're telling me it's DAEs, right? It's systems of DAEs.
Right. It's
and they're things that clearly cannot be modeled as
DAEs. Yeah, but I mean.
Okay, but if I want a cellular automaton in the loop, can I have it or can I not have it? Or does it fundamentally not work in that model?
In the general case, Modelica has a C interface, so you can have whatever you want in it.
Well, but does that work with what we have here?
Yeah. I mean,
so then why wouldn't it be the
interface is going to be it's not going to go into the
why
C
wouldn't
interface.
we be able to have, I mean, you're talking about putting machine learning stuff inside these models. Why wouldn't we be able to have our PDE stuff inside these models?
I mean,
look at that too, but the interface to it is going to be kind of black boxish, right?
Yeah.
It's largely going to say, how does it communicate with the rest of the system?
Sure.
And that's, largely what goes on inside of it you don't know about. You don't.
Okay, but fundamentally what you're telling me is the the thing has a finite number of tentacles. Every component has a finite number of tentacles, a finite number of variables that are relevant. I mean, so for example, I was just talking to somebody about old Mr. Babbage's mechanical notation, okay, which was an attempt to, so he had things he called, I think, train diagrams, which were how is something connected to something else. And he had what they called unit diagrams, I think, which were some kind of timing diagrams about how things worked. What is the modern analog of that?
Those are called, so you do it when you do, for instance, relay ladder logic and other things. So those are usually called, I think, event diagrams, because he doesn't really model the continuous movement of them. He's primarily focused on events. Is this, make sure that this finishes before the next thing
that's
starts.
correct. Yeah.
And you have similar kind of sequencing things going on, at sort of a macro level. At the macro level model, which doesn't model the detailed behavior necessarily. And in fact, in System Modeler, there is something a little bit like that. They're called state graphs.
Okay. So what is the relationship? There's this thing, what's it called? Ladder logic or something, which is the thing used.
Yeah, that's what I was saying, ladder logic.
But so, and am I right in saying that, when you program a robot with like PLC type, whatever they're called, am I using the right terms? The dead reckoning robots. How do you program those? What's that?
What's a dead reckoning robot?
Well, I don't know. I'm using that term. I mean, a robot which just does one thing, right? Put this bolt and move the arm of the robot in this way
No, I mean, you rarely use that. I don't know exactly what the best current interface is to robot programming, but it used to be that you have to give a sequence of paths that it follows. And those are relatively simplistic paths.
Okay. But so explain to me, I mean, ladder logic is a subset of what System Modeler deals with. Is that correct?
Yes. State graphs generalizes that. So ladder logic was literally invented for relays, telecom switches and things like that.
Okay.
Although I was called in once, to revise a nuclear power plant, where they were concerned with correctness of this thing, you can imagine.
Always a good idea,
yeah. Yeah, should this pump actually always work, for instance? Would be a good thing. Or should I always be able to deal with this
So had they represented originally in ladder logic?
Exactly. The whole design was done in ladder logic.
So that
I bet if you pick a random nuclear plant here today in the US, they probably have their documentation in ladder logic because they are from the 70s.
But so the representation of that as a kind of simplistic programming language.
So the modern version of that, Stephen, kind of got inspired by, there's an academic version of that was developed for concurrent programming called PetriNets. And the industrial version of that are called GraphSet, or the version in System Modeler, or in Modelica is called state graphs. And they deal with concurrent events, sequential events, branching, and so on.
Okay, so that's interesting. So PetriNets, I mean, isn't Michael Trott working on PetriNets in connection with something about food recipes?
I have no idea.
I think so.
I mean, it wouldn't be unreasonable, because that's kind of what they used. They used as for, so you can imagine you're going to do recipe following for a chemical plant.
Yeah.
Well, that sounds pretty much like cooking to me.
Sure.
Heat this vessel up to a certain degree, stir it, and then insert this other ingredient.
Okay, so what's the relationship then between PetriNets
and so are also assembly plants, like a car assembly plant? So at that macro level, you view a robot as a black box. Do your thing, and when you're done, tell me. Then we start in with the next thing. And that's how operating system work too. You know what I'm saying? You do this process. When you're done, tell me. Then do these parallel.
If we were going to have a general representation of PetriNets, for instance.
But PetriNets have the unfortunate thing of being, in general, unanalyzable because they have unbounded state. So the industrial version doesn't have that.
How does it work?
It has typically, finite, but it has timers and other things, which is also very practical and useful.
What's it called again, the industrial one?
So there's a European standard that's called GraphSet, which is the French name, and there's a German name called sequential function charts. And the version of it in Modelica is called state graphs.
Boy, I do not know all this stuff. Yeah, okay. So that's so we should understand this before Michael goes off and does, because
at the macro level, so you could imagine, at the macro level, even for a car, there are things that need to be sequenced.
Yeah.
And for an airplane, like a landing, if you're going to go in for a landing, there's a certain sequence of things you need to do and validate and be sure of, right? Or a start, or takeoff, I guess it's called.
Right.
And that's typical what happens in other industrial settings too. Like you're going to start up. I was at the ABB once, okay, and they built this giant fluidized combustion coal bed, which made plasma-like thing out of coal powder. It was a very efficient way of burning coal. But could you imagine how many pumps and valves and other things that needs to be sort of sequenced and initialized to just start one of those things or recover from a failure? And it was literally like a binder full of these diagrams.
Okay. But so you're saying that nowadays these could be implemented as state graphs for system model?
Yes.
Right?
Yeah. And there's something that's used for software systems that's not unrelated to that, which are called UML diagrams.
Right.
Okay. And there's a sub part of that called SysML, which is UML for systems.
So, I mean, UML is yet another one of these things which we've looked at implementing at various times and decided we don't care.
Well, and UML was derived from basically an Israeli guy designing hierarchical finite state machines called state charts. And it was originally motivated from a fighter project, as you could imagine, in Israel. That's its origin.
Mm-hmm.
So, yes, there's a lot of languages for modeling. And these slightly simpler things like state machines and so on are, there's particularly many formalisms for that.
But so we've got finite automata, we've got Petri nets. I mean, those are the two kind of mathy versions of that type of stuff.
Kind of.
And we don't yet have a standardized finite automaton system.
No. And again, in this context, the finite automata is commonly described. I mean, there's many use cases for that alone, but the one that's useful in the context of systems would be like a more Mealy machine, not just the autonomous.
A transducer of some kind.
Right.
Yeah.
So
it feels to me like we need a more general story here. I mean, that system model is.
I think that it's, I think that the space of problems that this addresses is, I'm not saying it can't be extended, but I think it sort of hits the use cases pretty well.
Well, okay, but still, look, Roger, this is the anti, what you're saying is system model hits a bunch of popular use cases. What I'm now complaining about is what's the general framework that it lives in, right? Because it could be that if we generalize this framework a bit, that we could use the machinery of system model to implement a bunch of this as a kind of it's a trivial, given what system model does. But nevertheless, those things might actually be quite useful. Although
I know, but it needs to be, for that to be useful, that it needs to integrate with, and we do extend the range of system modelers, always. There's always those extensions going on. And a lot of it can be, in fact, implemented as new libraries, is what I'm saying. Let's say that you wanted some particular finite automata, some other variant of finite automata. Yeah. That can be typically modeled and implemented as an extension, as a library.
I understand, but that's not how you'd want to do it. I mean, some complicated reachability thing for a Petri net or for some kind of finite state machine state minimization, right? We're never going to implement that as a function for general system model because it won't work, right? But state minimization, for example, is something that we could very well want as a function for finite automata. And just saying, oh, you can make it a library of a system model, we'll never put that in there. I mean, there's a value to having.
No, I don't disagree, but I don't think that this is. It's. There's a lot of things that one can do. Let's take an example of something that is in there. Okay, like block diagrams.
Yeah.
Okay, so the most common case of block diagrams basically correspond to constant coefficient systems of differential equations or difference equations.
Okay.
That's exactly our state space model object in Mathematica.
Okay.
Or transfer function model object. Those two sort of different ways of saying the same thing. And now there's a ton of things that you can do to manipulate those systems. In fact, we have whole subsystems that do that in Mathematica, like for control design or observer design.
Okay, but so, for example,
so in other words, the system modeler doesn't do that. System modeler's job in life is to simulate it. It's the primary job.
So for example, I'm a sometime consumer of finite automata, right? But my use case for finite automata is absolutely not captured by all of these things. My use case is.
No, I realize that. But I think that we need a more extensive kind of support for finite automata in Wolfram Language.
Yeah,
I know it's a different thing. It's closer to graph in spirit than system.
All right, but I mean, if we look at this complete picture from ladder logic to all this state graph stuff and so on, there's this question that I have of, if we were just to imagine, independent of the difficulty of implementation, what will we want the design to be? I mean, at some level, just like we have.
But we want sort of a bridge, right? Let's say that you design a finite automata through some programmatic way of deriving it and minimizing it. products.
And then you want to put it into an elevator. You want to be able to take that finite automaton, put it in a system model, have it be part of an elevator.
Sure.
Right.
But there are many. What I'm saying is that there are many bridges for finite automata out to various parts of the system, including system modeler.
Fine. But I mean, also things like this ladder logic thing. I could imagine that since that's a known and obviously useful formalism because it's been around for 50 years or something, one could imagine even having a wrapper called ladder logic in which you put various things, and where system model of ladder logic or something can transform it to a more general system model.
Right. Then it can integrate with lots of other parts of
Right. So for example, if I had a ladder logic thing, maybe that corresponds with some simple input and so on, just to a function.
Yeah, I mean, it's a state graph. I mean, it would largely be modeled as a state graph today, because it's trying to address the same problem.
Okay, but we have no direct representation of a state graph. Is that true?
No, I mean, we have it in system modeler.
Okay, but so as an example, if I wanted to take a system model and I want to output the graph that corresponds to the connection between its components, can I do that?
Not as a graph object, but I think it does allow you to retrieve the connections.
Okay, but why not as a graph object?
Because it has ports, which are not a feature of the graph object in Mathematica, as far as I know.
Well, but maybe okay. I mean, they certainly could be by having just an external node on the port, so to speak.
Right. I mean, internally, we do, for some use cases, we do actually create a graph of these connections. For example, if you create a system model with a bunch of components and connect them together, we want to do layouting of these components graphically on the diagram view. And we do that by creating the graph as a graph object or as a slightly modified graph object in Wolfram Language, and then use the graph layouting in Wolfram Language to compute the positions. So, but
okay.
I don't think there is a user-facing way to get that graph because it's not directly useful.
Well, so you say.
Yeah.
I mean, look, if the goal was, oh, this thing actually turns out to be a finite automaton, get me the graph of the finite automaton, then it's plenty useful. I mean,
yeah, I'm sure I can imagine advanced use cases where it would be useful.
Right, but I mean, the thing I'm trying to get a sense of, look, the thing I'm trying to get a sense of for all of this is, I don't understand the space very well of all these different kinds of models of, and I'm just trying to check that. I mean, the models that I know about tend to not be models that are in these DAE, in this DAE world, right? They tend to be homogeneous models. A model of I don't know, the early universe. It's not a DAE model; it's a PDE.
Sure. But if you browse the standard library, you get a sense of the scope of what it models well.
Yeah, I understand, but I'm looking at these names like system model, and I'm trying to understand I mean, I don't think it's a terrible name, but I'm just trying to understand what we can grandfather into that system model wrapper.
I see.
Okay? Because, I mean, what we're talking about here is the de-experimentalization of, that core name and its features, right? And I'm trying to understand whether, if in the future we have ladder logic or something, whether we can expect this system model wrapper to be something where you say system model of ladder logic and have it all just work.
Right. I mean, we have something similar. I mean, you can currently do a create system model of a state space model or a transfer function model in Mathematica, and you get a system model back.
Why does it work that way? Why doesn't it just system model of the state space model?
That's a fair point, but create system model also has other forms where you can give it things like equations. So you can literally
Why
write
doesn't
your
system model
DAE.
equations work? I mean, I can ask the same question there. I mean, that would be a common way that we've done this in other places. I'm not necessarily saying it's the right thing here, but usually a create function creates a persistent thing, whereas a system model is not a persistent thing. It's just a thing hanging out in memory, right?
Yeah, until you save it.
Well, how do you save it?
Either by opening System Modeler or by doing export.
Okay, so doing export, doing export will be how you'd save anything, right?
Right. I mean, it could probably be shoehorned into the system model function itself, but
much easier for things
harder.
like state space model than differential equations, because there you have a bunch of
Yeah.
names, you need a bunch of extra arguments to wrap it all up.
I mean, to be honest, I don't think this is quite the right design, this create thing. I think that create is really something we try to do to make persistent things. I think rather here it's a wrapper where it will be ultimately system model of, I don't know, system model equations of something or something like this.
It's going to make the documentation of the system model page even harder. It's already very complex.
I don't care. We've got a pattern in the system that create X creates a persistent object. This is not doing that, so its design is wrong. Okay. Now, and we should not de-experimentalize it and burn that in forever. I mean, this clearly, look, to my mind, it will be very useful. And Roger, I mean, we can talk about this some more at a different time, to just get yes, it's pie in the sky, but a version of what the whole thing would look like with ladder logics and UML and so on. What would it look like if it was a global view of these kind of sequential, kind of connected sequential thing? What did you call it? Compartmental, what did you call that?
We're mixing metaphors. So if you're trying to model a PDE with an ODE, it's usually called a compartmentalized model.
Okay, fine. But you had a name for this general class of things, of which UML and ladder logic are two examples, and state graphs are another example.
Yeah, so they are. I don't know if I gave a name for that whole class of things, but they are typically modeling. They're sometimes called discrete event systems.
Okay. Well, anyway, so what I'm saying is, it would be very, very, very useful to try to get sort of a pie-in-the-sky global view of what all this stuff would look like, including the agent-based model stuff and so on. Because I have no sense of whether those are close to this or whether they're a different branch altogether. I mean, I understand that the full world of models is like the full world of math or the full world of lots of programming or whatever. It's it's an infinite kind of thing with lots of different tentacles. I'm just trying to understand what things, with the basic formalism that we've developed for system model, what other things kind of match the patterns of that formalism? Okay, and which forms of modeling, because what you're doing here is you're creating a model, then you're simulating. That sounds like a fairly general workflow for many kinds of modeling, right? Am I making sense? But I'm trying to understand to what extent that's true. That's not the case. Yeah, I mean.
So what we've done in general is that the core mission for System Modeler is just that: model and simulate. And then there's sort of a set of workflows in and around that. You need to be able to import and export to other modeling systems. Because often I can go on and talk why.
No, I can see that. I could see that would be the case.
But if you want to do analysis of it, or you want to do design, so in control, design is an algorithmic procedure that computes a system, that derives a system.
Yes.
Those things happen in the Wolfram language, because that's a system designed for doing those kinds of things.
Okay, when you say it happens there, it's like you have these things where you have series and parallel connections and things like this. Is that part of this whole story, or?
Right. I'm saying is if you're not going to manually design it, meaning like using the GUI to wire things up to model something, or, you know, God help you, you create a new domain, so you need to build a library before you can model efficiently. If on the other hand, you want to do programmatic analysis of how is this performing, you know, how's this metric turning out, you want to do a lot of it. If you want to marshal all that, or if you want to automate the design, like control design.
Yeah, or these generative design models and things like this, yeah.
Right, that happens in the Wolfram language. That's the system that's designed for those kinds of things. System modeler is not. It's
yeah, I understand.
For
system modeler is at some level, it's like a big version of ND solve.
Sort of, yeah.
I mean, and that's part of the loop that you might need to do some kind of parametric design, but it is not the design itself.
That's right.
It.
Yes.
Yeah. Now, I mean, yes. I mean, and you know, for example, it'll get more complicated with neural networks, right? Because I mean, we want to use you know, we want to use system model as the system model mechanism as a component in reinforcement learning, right?
For instance, so there's several scenarios for neural net and machine learning. One is that there's an even simpler one, which is that let's say that you model the world instead of measuring the world. Modeling the world is usually a lot cheaper than measuring the world.
Sure.
And that's the fundamental property that makes model-based engineering be such a success. It's a lot cheaper.
Yeah.
And you can do things that you can't even do in real life. And in particular, for machine learning, that gives you, once you've built one of those models, that gives you an infinite set of data to drive and train those models.
Exactly,
because, yes. You know, getting data is super expensive for machine learning, which everybody's learning now.
Yeah. Right.
Okay.
No, I understand. So,
and then there is just what you brought up too. But there's multiple kind of use cases for that, is what I'm saying. Right. Reinforcement being one, you know, which is.
I understand. We're not ready to de-experimentalize this stuff. However, and what I would really, really love to see, as I say, is this global roadmap of where do we go from, you know, how do we connect, on the one hand, finite state machines.
I know, but I can tell you very near term, and this is something we've been working for a long time, and our users, our customers really want it. It's key, is to conquer fluid dynamics.
Right.
Okay. And we're almost there, just almost there. And that sort of more or less completes our support for Modelica.
What do you mean? Fluid dynamics with PDEs, like solving Navier-Stokes, or you mean fluid mechanics as in some discrete sort of ODE?
So it's used as ODE, you know, so for instance, if you want to model an HVAC system, and you need to model the fluids involved there.
Yeah.
Okay. So there is quite a lot of engineering systems that rely on that. You know, to how to transport heat and how to model those flows.
Okay, but you mean by fluid dynamics, you do not mean CFD of flow past an airplane. You mean
Okay. No, I don't. You know, I mean, there's some overlap, but exactly characterizing what that overlap is going to take us a little, you know.
Yeah. Well, anyway, look, it would be great to see a roadmap of what the general modeling, you know, I mean, I've thought about a model repository that would have, you know, random models like, you know, diffusion limited aggregation or something in it. But I don't quite understand how to make the interface to those models general enough that it's useful to put them all in one big repository.
Yeah. I think, I mean, this probably, it runs into another meeting, but that we should have. But getting a kind of a core introduction to what is actually there in the Modelica world, if you like, which we've been part of creating. We were founding members of the Modelica Association and been driving that standard. But part of the benefit there is that there's already effectively like a marketplace of people developing these libraries.
All right, let's have a separate meeting about this. I agree. I mean, I just really like to have something which spans the finite state machines through CFD, agent-based models, and so on. What is the map of the world of modeling? And how do we make sure to signal which parts we're biting off with what functionality?
Sure.
But we're not going to de-experimentalize this. There were some questions on our live stream here from Carl. Some live streams of a Wolfram U course about system modeler integration with Wolfram Language. It seems useful, but I don't know where to start. What is there?
So we have a suite of courses that are being revised and updated over the fall and probably a little beginning into next year.
What's the title?
They're covering modeling, and they're covering analysis, and they're covering design. So I can't remember the details. Actually, we had a meeting this morning, and I asked for. I didn't like what the titles supposedly were. So
it is important. I mean, look, for somebody like me who is not, didn't grow up in the engineering world, okay. It doesn't really, system model as such, it's, the name is okay, but it doesn't really do much for me. I don't really understand what it is. And if you start saying modeling in general, I'm going to think, cosmology modeling and things like that, which really is of a different character than what you're talking about.
Yeah, sure is. But there are all kinds of, I mean, look, we have, just to bring that up, and I've said this for 20 years in meetings that we've had.
Mm-hmm.
Modeling means a lot of things to different people. You can build optimization models. That's something that we haven't even talked about, but we now are getting very good at supporting.
Yeah.
The new functionality in 12 there points to how you do that. It's a fairly large scale.
Right.
We can do stochastic modeling of various levels.
I know. Yeah, right.
Okay. And we support that too quite well.
I mean, this is where it's like the weirdness of, ladder logic meets options pricing.
Well, yeah.
Because, I mean, there are somewhat similar things, right? I mean, there are things where you can say, I have this particular, financial instrument that has this particular logic about how it works and this flow from, you open this door and then this thing closes and so on.
Well, that's kind of correct, yes.
But I mean, those are two completely different branches of the world.
But we've been bringing them together. So over the last, I don't know exactly, I can't remember. Well, for instance, we have extended NDSolve and DSolve to both cover DIEs better and also cover what we call event systems.
Yes.
And those were largely inspired by this.
Mm-hmm. All right. Anyway, look. Separate meeting about this topic. It will be very interesting. With an attempt to map out, because I mean, I've also made some maps of. So I was thinking about a model repository, okay, and it didn't really work out. I couldn't really understand what to do because, as I say, these models tend not to have well-defined modular tentacles hanging out of them, so to speak.
Right. So Modelica is a systematic way to build that in a way.
No, I understand. It has a way, but I mean, using the state graph formalism or whatever it is, that is in a sense, if I'm understanding correctly, it's like, how much momentum flows into this thing, how much energy, how much this, how much that. And it's a way of modularizing, or is that not correct?
Right. You're mixing a few metaphors, but yes.
But I mean, any given component has a finite list of tentacles. Is that a fair statement?
That's a fair statement. That's a fair statement. But each library is its own little modeling world, even if they are all expressed in Modelica.
Yeah, I get it.
But they map to the domain in question.
And we've never really tried to do this thing. When we consider doing it,
but the beautiful thing is that you can cross engineering disciplines. Do you know what I'm saying? It's multi-domain. And it's because if you build a real world system, chances are, like if you take an electrical motor, is an electrical component and mechanical component, and they're one and the same. So if you have a purely electrical, like spice or something like that, you can't model the mechanical components. If you have something that's purely a mechanical modeling system, like
well, I don't understand to what extent are the tentacles complete, so to speak, of some particular thing. Like, there's a resistor, but probably in the electrical modeling part of it, the fact that it is, 1 centimeter long and weighs this amount doesn't even
complete.
Enter.
That doesn't even enter. But you'll be surprised that it actually modeled the thermal properties.
Yeah. Okay. Fair enough. Well, okay. Look, something for another day.
Sure.
Okay. But yeah. All right. We should try to do this within the next, let's say, month. We should try to at least get a meeting to try and map this out, to try and see, the goal is, is there a model repository? Is it basically, could it be done with Model? Actually, I'm sorry, I was asking that question. What happened to like a decade ago, we talked about a Wolfram language mapping for the full Modelica language. Whatever happened to that? Is that still a good idea?
No, I mean, we talked about and discarded. So right now it's that would be a major project to do.
I understand, but it might be worth understanding whether that project, if done, was some would give us a general way to think about modeling and modularity of modeling.
Yeah, there's some hair with Modelica because the Modelica language it reminds you kind of C++ with objects and
I know, I've seen
and all of that. Now, none of that is particularly complicated per se, but it gets pretty hairy in details.
Okay, so Carl on the live stream is asking, do I need a system modeler license to use the Wolfram language integration? The answer is, if you want to author using the GUI, you need system modeler. If you have got a component, for example, from the standard library, or you construct it programmatically, then you just need Wolfram language. Is that a fair statement, Roger?
Yes. So it's basically a player plus. You can, in fact, programmatically create models.
Right.
And so sometimes that's actually very useful. But the most productive way to create models most of the time is to use GUI and sort of drag and drop components.
Right, which is what System Modeler, the product, does.
Right.
Yeah. Well, the fact that Carl is confused about this point means we are not communicating it that well.
Right. For starters, I usually call the features in Wolfram language the system modeling features. There is no system modeler in there. But yeah, it gets confusing.
Right. Well, so this should be called system modeling, Raj. Okay. Yep. One last point from our live stream. Ethan is commenting that he wants to be able to do tens of gigabytes of resource data, net models, and so on. Yes, well, we have now the wrong people in this meeting to discuss that. That would be a good. Can Devin? Is that who's? Yes. Can you make sure that gets on the subject on the agenda for the next resource system meeting?
Yeah, sure.
That would be a good thing to push again. I think we're ready to push that.
Mm-hmm.
Right. We are really over time, but let's see if we can't very quickly dispatch synthetic geometry. We may not be able to. Do we have the relevant people here for some synthetic geometry?
Yeah, I'm here.
Yeah.
Okay. So how much of synthetic geometry is already de-experimentalized?
None of it. It was all came in 12.0 experimentalized.
Even things like triangle center. Okay, right, so every function is we're not going to be able to get to that today. I mean, each one of these has its own whole story. And probably mostly these are fine, but I think I want to look at them one more time before we de-experimentalize.
Okay, I'll put it in the next agenda.
I think we have to wrap up here. All right, we're not de-experimentalizing that much, sadly. but I think it's useful to plow the field, so to speak, and see what's happening. Even if we don't succeed in de-experimentalizing a lot of things. Okay, so I think that's probably it for today. Is that right, Raj?
Yep.
Okay, we got a bunch of background noise from somebody there. Okay, well, thanks a lot, everybody. Thank you, people on the live stream. Until the next time.
All right, thank you.